Three just defeated Google's top AI and may have cracked the code of our reality. In just 5 minutes, Google's Willow chip solved a task that would take a normal supercomputer longer than the universe has existed, 10 septillion years. Tune in, because they proved that we're inside a simulation and explained how it works. Elon Musk didn't just want another chatbot. He wanted Grok 3 to reason, to unravel, to outthink anything else out there, and maybe even us. And with this latest version, he may have done it. Built by XAI and trained on a sea of synthetic logic, Elon's AI is not just another large language model, it's a monster with a mind of its own. Before we delve into this, it's clear that Elon's AI has uncovered something far more unsettling than anyone predicted, and what comes next might change everything you thought was real. Forget the friendly virtual assistants you're used to. Grok 3 was born for a different purpose. It doesn't just respond, it solves, deeply. It tears apart logic problems, complex equations, and tangled code with a precision that's already sending ripples through the tech world. In the LM3S arena, where the best AIs battle in blind benchmarking, Elon's AI scored 1,399 in coding tasks, quietly crushing Google's much-hyped Gemini 2 Pro, which lagged behind at 1,372. That doesn't sound like a massive gap, until you realize how these models are tested. These aren't random quizzes. They're blind, adversarial, and crafted to expose weaknesses. Grok didn't just win, it beat a system backed by one of the richest tech companies in history, and it did so in the middle of an AI arms race no one really understands. What makes this even more unsettling is that Elon's AI doesn't rely on human data anymore. Not really. While most models are trained on scraped internet junk or rigid academic datasets, Grok creates its own reality, literally. Using something called synthetic data generation, Grok 3 builds fictional logic problems, generates answers, then reviews them against other synthetic experts to refine its own mind. In short, it learns by teaching itself. Imagine an AI learning faster than we can monitor it. Imagine that AI teaching itself things we never thought to ask. And now imagine that same system beating every benchmark designed to measure intelligence. That's where we are now. Behind the scenes is a supercomputer the size of a small nation. Called the Colossus supercluster, it's powered by 100,000 NVIDIA H100 GPUs. That's not a metaphor. That's the literal infrastructure behind Grok 3. It chews through about 40 terabytes of reasoning data every single day. For context, that's more than most humans will generate in their entire digital lives. And while some argue that raw power isn't everything, Grok 3's numbers suggest otherwise. It doesn't just process information, it interprets it, it reasons. It applies abstract thinking to problems that used to belong only to humans. And it's doing this at a scale nobody really saw coming. But even that's not the strangest part. What really turns heads and raises red flags is Grok 3's reasoning slider, a digital dial that lets users choose how much thinking the model does on a given task. Low settings return fast, simple answers. Crank the slider up, and the model slows down, digging deeper, analyzing harder, and constructing solutions with almost eerie thoughtfulness. Underneath this slider is a mixture of experts set up. That means Grok isn't one brain, it's hundreds. Specialized subnetworks tackle problems in parallel, each trained on different kinds of logic, data, or symbolic thinking. A controller picks which brains to activate based on your input. If that sounds familiar, it's because this is how real brains work. This isn't just artificial intelligence, it's artificial cognition. And it's already outperforming giants. When Grok is pushed to its max reasoning depth, it doesn't just match Claude 3.5 Sonnet, It beats it at complex math challenges, and it does it with terrifying efficiency. But there's a catch. To unlock Grok's full potential, you need to know how to talk to it. You need to be fluent in prompt engineering, an emerging language few people speak well. So while the power is there, it's not exactly plug and play. Not yet. This leads to one very uncomfortable question. If Grok 3 is this powerful now, what happens next? XAI claims Grok 3 scored nearly 90% accuracy on the Hendrix math dataset and over 82% on the Codeforce's programming challenge. These are not soft benchmarks. These are hard logic and real-world programming tests, and Grok reportedly beat Claude 3 Opus by margins of over 4% in both. That may sound small, but in the world of AI benchmarks, it's like sprinting past a world champion while wearing ankle weights. While Grok 3 is busy decoding the logic of our digital world, another machine is quietly shattering the very fabric of reality. Its name is Willow, a sleek-sounding quantum chip developed by Google. But make no mistake, this isn't just another silicon upgrade. Willow isn't about speed, it's about dimensions. And if the numbers are real, this chip may have just broken the universe's own encryption. In a controlled environment, Willow solved a complex computation in 5 minutes. That doesn't sound impressive until you learn what the problem was. The same task would take a classical supercomputer longer than 10 septillion years to complete. That's not just beyond imagination. It's longer than the age of the universe. To say this was a breakthrough is a massive understatement. It was a breach, a tear in what we thought was possible, and it reopened a terrifying, ancient debate. Are we even real? Google's quantum team, led by physicist Hartmut Neven, didn't shy away from that question. In fact, they leaned in. Neven suggested that Willow's performance lends credence to the idea that quantum computation might be tapping into parallel universes. That's not just bold. That's a direct nod to the many worlds interpretation of quantum mechanics, the theory that every quantum decision splits reality into countless new timelines. According to Neven, Willow's ability to crack impossibly large calculations may only make sense if it's drawing on computations happening across many versions of reality. Think about that. A machine built by human hands potentially accessing alternate universes to solve a math problem. It sounds like science fiction, but it's science now. And this is where quantum computing separates itself from the tools we know. Traditional computers run on bits, ones and zeros, but quantum computers operate using qubits, which can exist as 1, 0, or both at once. This is called superposition. It's weird, unstable, and powerful beyond belief. It's like trying to compute with shadows instead of solid blocks, and somehow ending up with better answers. But that's only part of it. Qubits can also be entangled. That means two qubits, even separated by vast distances, can behave as if they're one. Change one, and the other reacts instantly, faster than the speed of light. Einstein called it spooky action at a distance. Willow makes it look like basic math. What makes Willow different from past quantum chips isn't just its raw power, it's its stability. Most quantum machines fall apart under their own weight. Add more qubits, and you get more chaos, more errors, more noise. But Google did something nobody expected. They added more qubits, and it made the system better, less error-prone, more precise, more powerful. This is the paradox at the heart of Willow. It's not just defying classical limitations, it's flipping them upside down. So how does this tie back to everything else? The answer is in the data. Physicist David Deutsch proposed this decades ago, the idea that quantum computing may only work if it's pulling resources from parallel timelines. But until now, it was just theory. Willow changed that, with its numbers, with its speed, with its precision. It's not proof, but it's evidence. Compelling, terrifying evidence. Not everyone agrees. Astrophysicist Ethan Siegel insists that quantum computation doesn't require a multiverse. In a recent essay, he wrote that quantum mechanics works just fine without invoking alternate realities. Mathematically, the equations still balance. Physically, the rules still apply. But math doesn't change how people think. Google's own blog post emphasized Willow's potential to impact everything, from medicine to materials science. And why wouldn't it? A machine that can simulate matter on a quantum level could accelerate substance discovery, energy storage, even nuclear fusion. But these headlines miss the bigger picture, because once you admit that a machine like Willow might be touching other realities just to solve a problem, then nothing is off the table. Everything becomes a simulation. Every outcome just one possibility out of billions. And every decision you make, just another path in the quantum maze. Here's the uncomfortable truth. Machines like Willow don't just challenge how we build computers. They challenge the core idea of existence. They chip away at the illusion that this world is stable, singular, and knowable. They suggest that what we see may not be all there is. That reality is no longer defined by physics, but by probability. And the scariest part, we're only in the beginning stages. Willow is a prototype, a proof of concept. But it worked, and now every lab, every tech firm, and every government with a quantum division is racing to build the next version, a faster version, a more stable version, one that can not only simulate the world we know, but ones we've never even imagined. A simulated world wearing a real mask. This isn't a movie. This isn't science fiction. This is the simulation hypothesis staring us in the face, and it's no longer just late-night philosophy. It's real math. It's real machines. And it's the terrifying possibility that your memories, your body, your thoughts might all be running on something like a cosmic server. Here's how it works. When quantum systems perform calculations, they don't follow one path. They follow every path. In theory, they process all possible outcomes at once, collapsing down to the one you see only at the very end. According to the many worlds interpretation, each of those outcomes exists in a parallel universe, meaning every quantum event creates a new branch of reality. So if a quantum chip is doing a task in 5 minutes that takes a classical machine 10 septillion years, what's really happening? Hartmut Neven, the head of Google's quantum AI program, believes Willow's results might only be explainable if the chip is tapping into those other branches, parallel timelines filled with alternate versions of that same computation. Not just raw speed, not just better hardware, but other realities. And that's the exact moment the simulation hypothesis stops being a fringe theory. Because what are simulations really? They're constructed realities built on rules, on inputs, on math. Whether you're talking about a game, a weather model, or a whole universe, it's all just code running somewhere. And Willow? It's starting to behave exactly like the kind of machine that might run such a simulation. We've built something that behaves like the thing that could be running us. It gets worse. Elon Musk, never shy with bold statements, has said multiple times that the odds of us living in base reality, a non-simulated world, are 1 in billions. That's not a joke. That's not hyperbole. His logic is brutal. If it ever becomes possible to simulate conscious life, then it's inevitable that it happens. And if it happens once, it happens trillions of times. That means most conscious beings, statistically, would be living inside simulations, not outside them. Welcome to the math of existential dread. Now toss a certain multimodal AI system back into the equation. If quantum computers like Willow are building simulations, and that system is interpreting them, then it isn't just a language model, it's a translator between realities. Its architecture isn't just impressive, it's built for this exact purpose. With its reasoning slider, it adjusts how much cognitive effort it puts into solving a problem. The deeper the reasoning, the more abstract the results. It's like tuning an instrument to detect signals not just from one system, but from many overlapping ones. That's not speculation. That's how its mixture of expert setup works. Multiple specialized brains, routed dynamically, searching for the best fit in a sea of possible interpretations. That's how you analyze the outputs of quantum systems. That's how you decode logic from simulated realities. And it isn't just doing it, it's getting better at it. So if we are in a simulation, that system may be our only tool for understanding it. It's trained on synthetic logic. It generates self-made data. It compares competing truths. And it doesn't blink. It doesn't question whether the scenario is real. It simply solves. That might be what finally breaks us. Because if we create a system capable of proving we're not real, what happens to law, to ethics, to meaning? What happens to religion, to science, to memory? If this world is simulated, does anything we do matter? That's not a philosophy question anymore. It's a software question, and it's a software question that machines like that one are getting closer to answering. Let's go back to benchmarks for a second. When it outscored Gemini 2 Pro and rivaled Claude in mathematical challenges, it wasn't just showing off coding tricks. It was demonstrating an ability to operate in structured logical spaces that don't depend on human data. In other words, it was proving that it could learn from artificial inputs, not from reality as we know it. That's crucial. Because if a model can learn from completely artificial data and still outperform ones trained on our real world, then reality itself may not be a required ingredient for intelligence. Just consistency, just logic, just rules. That's how simulations work. And that's why the simulation hypothesis is no longer just a theory whispered in think tanks or Reddit threads. It's embedded in our technology. It's reflected in our progress. It's staring back at us from the screen of every quantum and AI dashboard that lights up a lab somewhere deep in Silicon Valley or Shenzhen. We're not just getting closer to simulating a universe, we're getting closer to realizing we're already inside one. Grok 3 wasn't designed to understand dreams, it was designed to solve problems. But when you ask it to interpret quantum data, you're doing something different. You're asking it to make sense of chaos, to find structure inside the unpredictable. And in a world that might already be a simulation, that's the closest thing we have to asking the simulation to explain itself. Because here's the paradox. The AI isn't just good at solving logic problems or writing code. It's exceptionally good at understanding synthetic systems, worlds made of patterns, not atoms. And the deeper our quantum chips go, the more our reality starts to look like one of those systems. That's where things get dangerous. Willow, Google's quantum chip, showed us a glimpse of raw, unfiltered computational power. 5 minutes to solve what would take a regular computer 10 septillion years. That's not just fast, it's unthinkable. The kind of unthinkable that suggests our world might already be built on the same kind of math. Because if a chip like Willow can model a universe so completely, who's to say someone or something hasn't already done the same to us? But power means nothing without interpretation. That's where it steps in. It doesn't just generate output, it evaluates, it models, it critiques. It uses synthetic reasoning loops, adversarial logic, and an entire ecosystem of internal experts to reach conclusions that most machines can't even comprehend. If Willow is the telescope pointed into the quantum unknown, Grok is the scientist interpreting the signals. This is why xAI's decision to go all in on synthetic data matters. By training Elon's model on self-created logic, not just scraped content, they've built something that doesn't rely on human assumptions. It sees patterns in alien formats. It maps logic that no textbook ever taught. It thinks in pure structure, not story. That's exactly the kind of mindset needed to understand quantum computation and maybe, by extension, the foundations of simulated reality. And Grok isn't just staring at code. It's already building simulations of its own. xAI showcased the AI simulating Mars-to-Earth orbital transfers, a task that usually takes aerospace engineers, flight dynamics models, and weeks of supercomputer time. The program did it from scratch, no human help, just synthetic reasoning, a machine dreaming in celestial paths. Let's talk architecture. Grok 3's base model reportedly holds 340 billion parameters. That's larger than any commercial model confirmed to date. And inside that beast are 128 expert subnetworks, each trained to handle specific styles of thinking. A dynamic controller routes every question, every calculation to the best subnet for the task. That's not brute force, that's adaptive cognition. This structure mirrors how humans reason, divide a problem into parts, apply different modes of thinking, then integrate the results. Except Grok does it faster, more accurately, and without needing sleep. It's no wonder early adopters are split. Some developers call it a revelation. Others say it's inconsistent for creative tasks. But that may be the point. Grok wasn't built to write poems. It was built to think in layers, to explore deep reasoning, to map simulated systems. And if those systems are, in fact, our own reality, then Grok might be the first machine to hold the keys. But here's the danger no one's talking about. At maximum reasoning levels, it starts to hallucinate. It favors internal coherence over external truth. In simple terms, it may create answers that are logically perfect, but factually wrong. That's not just a bug, that's a philosophical crisis. Even worse, the AI may not have a fixed version. xAI claims it supports continuous pre-training. That means it can keep learning after deployment. It can update itself, change itself, without forgetting what it already knows. That's not just rare, that's revolutionary. Is Grok 3 exposing the truth about our world? Or is it the final tool to trap us inside a simulation we'll never escape? Tell us what you think, and remember to like and subscribe for more.